to do the derivatives of parametric functions. And so I want to find dy dx. And doing the chain rule, I can find the derivative of y, whoops, with respect to t, right? That's equal to what? G prime of t, right? Okay, but I want dy over dx. What if I have, what's dx dt? That's what? F prime of t. So, what is dy dx? How can I use these two together? What if I took dy dt and divided by dx dt? Right. I would get dy dt is divided by or times dt dx. And what happens to the dt's? They cancel. So that is what dy dt is. So I just take the derivative with respect to time, or t, on both those functions and divide them. You have to know this. This is a free response question on the BC exam. Every year. I haven't seen it where it hasn't been there. And then dy dx. Oops. Okay, and I kind of wrote it there, but this is the summary of what you have to know. Now, that's the easy part. Remembering that. Now, that is the slope of the tangent line to my function. Can I graph it? You have to be careful about what dy dt is and what dx dt is. And you'll see it in the context of the problem. So that's the big thing. Oh, I could use my magic pen. There you go. That's what you have to know. It's usually going to be in the calculator section. It's going to be with vectors. So this is vectors as well. Okay, let me write that down so we have that. This is parametrics and vectors. The problem is going to be the time issue. Not that you don't have time to do it on the exam, but finding the time. Well, let's do a problem. Should have a problem here, right? That's right. You should. If you're ever absent, handouts will be in the other. Okay. Let's look at what if we have a horizontal tangent. So let's say this is our parametric curve. The curve has a horizontal tangent when dy dt is 0. And what if you have dx dt? That's the change in the x as time changes. Well, if this is 0, because remember, what's dy dx? dy dx is equal to dy dt. That's what you have to remember. It's still y over x over dx dt. So if dy dt is 0, then dy dx equals 0 if dy dt is 0. What if dx dt is 0? Get your fraction there. What if dx dt is 0? Then you get dy dx is equal to dy dt, whatever that is, over 0. And that is a vertical. If you look at my picture, that's your dx dt is equal to 0. That's your vertical tangent. Whoops, sorry. And we'll do a problem. You might not have a vertical tangent. That's a cusp. But when you're given you have a vertical tangent, then you know dx dt has to be 0. Yeah, that's how you're going to do it. Now, what if now remember also, what's dy dt? It represents the what? dy dt is a slope, but it's also what? The velocity in the y direction. And what's dx dt? The velocity in the x direction. You guys have done this with vectors, right? If you have a velocity in the x direction and a velocity in the y direction, you get the resultant vector. Remember that from physics? Okay, if you try to swim across a river with a current, you're going to have to worry about those things. Okay, what if I want the object to be stopped? Then what would have to be true about the velocity in the y direction? If I want it to be totally stopped, That would be 0, and what about the velocity of x? You have to have both to be totally stopped. It might say it stopped moving horizontally, in which case then dx dt would be 0. Or it might say it's not moving up anymore. I'll have to find that problem. It's like a plane, and you can see that what's happening here. Only one of them is going to be 0. Oh, yeah, I remember that problem. Okay, so let's do an equation of a tangent line to a parametric curve. If you want me to get the parametric curve and figure out what it looks like, we can, or we can just do the problem. Let's do the problem. I don't know what it looks like. Maybe a Lissajous pattern, you know, one of those circle thingies that does this. It does other things too. True, and I can't draw a true Lissajous very well. But anyway, I want the equation of the tangent line saved there. And this one's not bad, but except that I have to be careful. X is equal to the square root of 3. That is not the time. So I need to find dy dx, because what's the equation of a tangent line? It's y minus y1 equals m x minus x. I know the y value. What's the y value? 1 equals m, and it's x minus square root of 3, right? All I have to do is find the slope. But the problem with finding the slope is I don't know what the time is. So that's what's going to be the hard part. Oh, if I hit my mouse, that's what happens. So, okay. Your homework going to be to finish 3-4. We're not turning in anything, so I'll just cut that out there. Good. Okay, so let's find dy dx. It's dy dt. We're going to use the chain rule probably. Over dx dt. I think I mistyped that. I think it's just 2 sine of t. Pretty sure. Okay, so otherwise I have to solve that. So what's dy dt? Oh, you guys know this? What's dy dt? 2 cosine of t. And you get points for writing this out, even if you don't know what the time is. What's dx dt? Now, let's see. We have to use the chain rule. It's 2 times cosine of 2t times the derivative of the inside function, which is 2. Except I don't even want to simplify that because I'm going to put it in that ratio. So dy dx is equal to 2 cosine t, so it's not that hard, over 2 times the cosine of 2t. Because what's going to happen with one of the two? They're going to go away, right? What do I have to know? I want to find this. Slope is always a number. Some of you make it variables, but you can't do that. It's always a number. So what do I have to do? I have to find what? No, I need to find the value of m. I need the what? I need the t. This is the tricky part. But it's not going to be that tricky because it's always going to be special triangles unless you're given a calculator. In which case, then that is tricky. Because calculator is not always easiest. Okay, so this is the x. X is equal to the square root of 3. So the square root of 3 equals 2 times the sine of 2t. That looks like that might be hard to solve. Let's go and do the y's next. 1 is equal to 2 sine of t. That one's easier to solve. Do you remember how to solve trig equation? Solve for the sine of t. So we'll do the easy one first. So the sine of t is equal to what? 1/2. What's that angle? Okay, we'll draw a picture. This is 2, this is 1, this is square root of 3, this is 30 degrees or pi over 6. Now, if you go around the circle a complete time, what's the next answer? T is equal to pi over 6. When is the sign also positive again? Do you remember this little mnemonics? All the students take calc. So sine is positive here and sine is positive here. So if it's 30 degrees, that's how I do it in pre-calc. You just have to count up how many of these 30 degrees you go. And I'm going to go over here because this is pi over 6. So how many have I done? 1, 2, 3, 4, 5. That would be the next choice. Usually it's the first one. Not always. And then you could go around the circle a couple more times if you wanted. You could go backwards in time as well. Okay, so how am I going to do this one? Should I do first? The square root of 3 is equal to 2 sine of 2t. So square root of 3 over 2 is equal to the sine of 2t. Well, forget that's t. Why don't we make the square root of 3 over 2 is equal to the sine of theta? No? The sine of what angle is the square root of 3 over 2? I want the square root of 3 over 2, that's pi over 3. All right, I haven't gotten there yet, though. The question was, what's theta? Theta is equal to pi over 3. I don't want to confuse people. Well, theta is 2t, so 2t is equal to pi over 3. So t is equal to pi over what? 6. And you could go on. The next one, when is the sine going to be a positive square root of 3 over 2? No, because these are 60-degree angles now. There's one, there's two. So you're going to go over two of these. So the next one, in case we need it, is going to be 2 pi over 3s. The sign is positive here and here and negative here and here. So my reference angle is pi over 3, or 60 degrees if you prefer. So the sinus of the 60 degrees in the second quadrant, which is 120, is going to also be square root of 3 over 2. So how many 60-degree angles do I count? 1, 2. So since this is pi over 3, and there are 2 of them. That's the easy way to do it. I mean, I could change 120 back to radians, or I could leave it in degrees. Who cares? It doesn't really matter. So this would be 2 pi over 3. So since 2t is also equal to 2 pi over 3, what's t equal for this? It's, what happens to 2? It's like, oh, pi over 3. So the next angle here, the next time, is pi over 3. I want where they first intersect, which is, I didn't have to go that far, but I might have to sometime in the future. Where do they intersect? They intersect at, because it has to be the same time for both of them, at pi over 6. If they hadn't intersected on the first one, you'd go to the next one. And the 2t values that make that happen. And then you just have to evaluate this derivative there. So what's the cosine of t? So t is equal to pi over 6. I'm kind of out of space, but anyway. The cosine of pi over 6, if I go back to my triangle, is cosine of pi over 6 right here. Square root of 3 over 2. So that's the square root of 3 over 2. And what's the other one I have to figure out? Oh, the cosine of 2t, right? So the cosine of 2 times pi over 6, which is the cosine of pi over 3. What's the cosine of this angle right here? 1/2, right? And then I substitute that into my derivative. If it's okay with you, I'm going to go back up unless you want me to copy it again. I can't. Why is it what? Not negative. And so now, maybe I can copy this. Can I copy this? I can. So we'll bring that down so it's not confusing if you want to go back and look at it later. And I just substitute those values right in there. So it's 2 times the cosine of t. Actually, you know what? I don't even want to simplify that. Because it's 2 times the cosine of t, which was pi square root of 3 over 2, right? And then it was 2 times the cosine of 2t, which is 1/2. What's going to happen to these 2's? They go away, these go away, and the answer is the square root of 3 over 2. There's only like 3 problems in your assignment that ask you to do this. I strongly recommend if you skip anything, you don't skip the parametrics. You probably need a little practice. I don't give you, as you know, I give you the easy problems, do I? No, you already know the easy ones. I have to stretch you. Yeah. That far enough? So I'm going to give you back. Who hasn't taken it? Some people should go take it. Brett hasn't taken it.